Problem on maximum power transfer theorem. In the previous video with respect to maximum power transfer theorem, we have solved the concepts and a sample problem. So here let's take up one more problem so that you understand much better. So I'm Mohan BS, working as assistant professor in Department of EEE SABIT. So in this problem, we have to find what is the value of RL, which is connected across, that would be connected across XY in such a way that we get maximum power delivered to the load. And also we have to find what is the value of maximum power. So as we are aware that we have to use Thevenin theorem by finding VTH, RTH, and we know the value of RL is equal to RTH such a way that the maximum power is transferred to the load. And the maximum power transfer is just 50% of the total load. So let's first find step 1. Let us find VTH. So where is VTH? This is positive, negative, and this is VTH. Let us solve by nodal, taking this as ground. Where the two junctions? This is one junction. Let us call this as VA. The other junction as VB. So by node voltage, we have to find two unknowns, VA and VB. So we have two unknowns. We'll have two equations. In all the two equations, in these two equations, we'll have two variables, which is VA and VB. Right. But if you inspect, we can say associate VA as 6Vx. However, what is this Vx? So you can see here they're given us Vx. So let's assume the current going in this direction as I. So by Ohm's law we can write Vx as R into I. And assume current is hitting positive, thus it is plus R into I. The value of R is 3 and the value of I by node voltage analysis is 6 minus VA whole by 3. So 3 cancels. So we'll have Vx is equal to 6 minus VA. Substituting this value in this place, so we'll get VA as 6 into 6 minus VA, right? So where it is 7 VA is equal to 36, or VA is equal to 36 by 7, 5.143 volts. So we get VA as 5.143 volts. So we started by saying that we have two unknowns, that is VA and VB, and we have inspected and associated the current source to VA. Thus we have only one unknown now, and that is VB. So we have to try to equation at VB to solve for. So let us apply KCL or nodal analysis at VB. So we know current entering is equal to current leaving. The entering current is 3 amp and the leaving current is only 1, that is VB minus VA whole divided by 4. So when we solve this, we'll have this as 12 VB minus 36 by 7, or we can simply say VB is equal to 12 plus 36 by 7, and VB is equal to 120 by 7, or which is also equal to 17.143 volts. So what is VTH? So VTH is actually equal to VB. So VTH is equal to 17.143 volts. So VTH is positive here, VB is also positive here, VTH negative is here, and then VB is negative is also here. And thus we can simply say VTH is equal to VB, which is 17.14 volts. And now let us find for RTH. So we know these are type 2 problems. What are type 2 problems? Whenever we have a dependent source, right, we have to find ISC, and then in turn we have to find what is RTH. So how do we find ISC? We need short circuit current. So in the place of load where it's being removed, let us short circuit, and we call this as ISC. So again, let us use node voltage analysis to solve. So we take this as ground and this as a junction. Let us take this as V1 now, and this is also our reference. We have only one junction. This is not a junction. So you can see here this point is ground, this point is ground, this point is ground, this point is ground, this point is ground. Similarly, this is also ground, this is also ground, this is ground, this is also ground, this is the X is also ground, until here. This terminal is also ground terminal. right? Thus we have only one junction, that is V1, and we can simply say by nodal that V1 is equal to 6Vx. And then what is Vx? So Vx is, let us assume the current, let us call this as I1, and this I1 hits positive, thus we take this as plus R into I1. What is R? R is 3, and what is I1? As we've solved earlier, it is 6 minus V1 divided by 3. 3 cancels, so we get Vx is equal to 6 minus V1. Let us substitute this here, so we get V1 is equal to 6 into 6 minus V1. Thus we have this as 7V1 is equal to 36, or V1 is equal to 36 by 7 volts. It's coming same in this case also, right? It will not be true always. Now, what about ISC? Now we can see the current, the voltage drop at V1 is actually 36 by 7. So what current is flowing through ISC? So if you see, if you apply KCL at this junction, right, we have 3 amps flowing and we have this current, I'll call this as I2. So when we apply KCL here, we can write I2 plus 3 is equal to ISC. And what is I2? By nodal, I2 is simply V1 by 4 plus 3 is equal to ISC. And we get ISC as 36 by 7 into 4 plus 3. And thus we get the value of ISC as 30 by 7, which is equal to 4.286 amperes. Right? So substitute the value of VTH, substitute the value of ISC, we get RTH as the value of VTH was 120 by 7, the value of ISC as 30 by 7, thus we get RTH as 4 ohms. So the Thevenin equivalent circuit, we have VTH, RTH, which is connected across the load. The value of VTH is 120 by 7. The value of RTH is 4 ohms, and thus the value of RL is as same as RTH, so that we get maximum power transformed. And then what is the maximum power transformed? So we can say P max is equal to I square into RL, and the value of I is VTH divided by RTH plus RL the whole square into RL. And thus substituting the value, the VTH is 120 by 7, RTH is 4, RL is 4, and here RL is a 4. We get P max is equal to 18.367 watts. So this is the maximum power that is delivered to the load. Thank you for watching the video. Please do subscribe the channel to see more videos and enhance your knowledge.